The next book is one of my absolute favorites. It's Counterexamples in Topology by Steen and Zeebach, and it's a brilliantly written book. I love it very, very much. So in it, we see some basic definitions, but the meat of the book is just a very, very long list of all kinds of very weird counterexamples, like the p-adic topology on Z, the right order topology, the Smirnov deleted sequence topology. And then at the end of the book, there are several appendices with several charts of where you can see, where you can look up the right counterexample. So here we see basic definitions, and then we come to the counterexamples. Here we see the long line, the extended long line, the construction, and all the properties, and a basic small proof of the right property. And then at the end, there are several tables. Several tables where you can see, for example, oh, I want the topology that is T4 and Urison and whatever, and you can just look it up in here. Extremely good book, one of my absolute favorites to ever have been made. It's such a beautiful, beautiful work. If you're into point set topology, this is a must-have. This is a must-have, definitely. I love it so much. Next, we have here Basic Algebraic Topology and its Applications by Mahima Ranjan Adhikari. Basic book on algebraic topology. So it starts with prerequisites. Prerequisites seem to be group theory, model theory, set topology. Then it starts off doing homotopy theory, elementary basic concepts, the fundamental groups, covering spaces. Then they do, they also go into Galois theory a bit. So they do fiber bundles, vector bundles, K-theory, geometry of simplicial complexes, and fundamental groups of polyhedra, the higher homotopy groups, CW complexes and homotopy, products in homotopy theory, homology and cohomology theories, Eilenberg-MacLane spaces, Eilenberg-Steenrod axioms for homology and cohomology theories, consequences of Eilenberg-Steenrod axioms, applications to all kinds of things, algebra, Kampen theorem, physics, chemistry, spectral homology and cohomology theories. We see a bit of obstruction theory, more relations between homology and homotopy, and a brief history of algebraic topology. Very good introductory book. It says it's basic, but I would call it basic. It's at least a graduate book. But yeah, I think it's very well written. I think it's a really nice book to go through. Even though I didn't do it completely, I did only parts of it. Still, I really think it's very well written. Worth a try, I think. Next, we have Differential Forms in Algebraic Topology by Bot and Tu. So yeah, this is all about algebraic topology and the RAM cohomology. So first chapter is the RAM theory. Then we have the Čech, the RAM complex, spectral sequences and applications, and finally characteristic classes. This is a very, very famous book, which means it's a hard book, as always. So yeah, it's differential topology. It's basically topology from the differential point of view, but it does to a lot of algebraic topology. So yeah. Next we have here a book, Topological Analysis by Vath, from the basic to the triple degree for nonlinear Fredholm inclusions. Kind of a niche book, I think, not so well known. So it's fun because the preface here states, this monograph aims to give a self-contained introduction to the whole field, requiring only basic knowledge of elementary calculus and linear algebra. So, okay, basic knowledge of calculus. So let's see. First up is topology and multivalued maps, metric spaces, spaces defined by extension and retraction of homotopes, advanced topological tools. Then we see some function analysis, orientation of families and linear Fredholm operators, some nonlinear analysis, the Brouwer degree, the Benevieri-Fourie degrees, then degree theory for function triples. Yeah. So this book that is completely accessible to basic calculus starts off with these things. You start off with ZF, axiom of dependent choices, Bayes categories theorem, obviously something a high schooler can handle. I'm not sure who this book is for, really. I don't think the book is for me either. I'm not sure I'm too interested in this stuff, at least not anymore. Here we see Fulton's Algebraic Topology, a first course. Love this book. Very, very good book. This is kind of a precursor to Bot and 2 that I just showed earlier. And it starts with calculus in the plane, winding numbers, cohomology and homology, vector fields, cohomology and homology 2, covering spaces and fundamental groups, covering space and fundamental groups number 2, where we see the Van Kampen theorem show up, cohomology and homology 3, where there's to check cohomology, topology of surfaces, Riemann surfaces, higher dimensions, and that's it. So yes, it starts off pretty basic. It starts off with basically the definition of a path integral. And if you don't know physics, this is a weird definition. If you do know physics, this is completely natural. This is something that you have seen many times in competing with work and force and whatever. And then all of these theorems seem quite trivial. If you don't know physics, then all of this is a bit overwhelming because you don't really know what's going on. If you do know physics, this is an excellent book. This is really a book that you will love a lot. It does algebraic topology in a very smooth way, a very beautiful way, with differential forms and everything. The proofs are very intuitive. The proofs are very beautifully done. I think I really like this book a lot. But if you're not ready for it, if you don't know physics, then things will probably be a bit weird and unmotivated. Because, yeah, I mean, you can know differential geometry and then it will be easy, but if you don't know either differential geometry or physics, I don't think you will get a lot out of this book. So yeah, I do like this book a lot. Very nice to work through, very nicely done. Yeah, I think if somebody like Mirror, for example, would ever want to do algebraic topology from maybe a non-conventional way, or Brouwer, for example, I think, yeah, this is really a book that they should want to work through. I think it's excellent. Next we have Algebraic Topology and Introduction by Messi. So it's a basic introduction. It's a famous book on topology. So we start with two-dimensional manifolds where they do orientable, triangulation, Euler characteristic. Then they go to the fundamental group, free groups and free products of groups, Seifert and Van Kampen theorem on the fundamental group of the union of two spaces, applications, covering spaces, the fundamental group and covering spaces of a graph, applications to group theory, a fundamental group of higher dimensional spaces, and an epilogue, and then there's some appendix on quotient spaces and permutation groups. Pretty dry book, I would say. I didn't particularly enjoy it that much, but everything is there, everything is rigorous, everything is done in a nice way. Just wasn't really too enjoyable for me. But yeah, a very famous book, of course. Here we come to Hussein, Takdir Hussein, Introduction to Topological Groups. Mir, I think, would enjoy this a lot. We have Fundamental of Topology and Group Theory, Semi-Topological Groups. Then we have General Theory of Topological Groups, Locally Compact Groups, Open Homomorphism and Closed Graphs, Haar measure, Finite dimensional representation of groups, Duality Theory, and some of its application, Introduction to Banach algebras. Yeah, it's an old style book. It's basically a book that people would have written many years ago. People don't really write like this anymore. You see what I'm talking about, right? Like very dense, very condensed, very old style. I don't really like to recommend these books, but it is pretty nice. It does have a lot of nice things to it. Next, we have here algebraic topology from a homotopical viewpoint by Aguilar, Gittler, and Prieto, which is, I think, one of my favorite books in algebraic topology. And it starts with function spaces, connectedness and algebraic invariants. We have homotopy groups, homotopy extension and lifting properties, CW complexes and homology, homotopy properties of CW complexes, cohomology groups and related topics, vector bundles, K-theory, Adams operations and applications, relations between cohomology and vector bundles, cohomology theories and Brown representability, and the proof of the Dold-Thom theorem and the Bott periodicity theorem in the appendices. Like any of Pireto's books, these are very nice. I really like his work. I really like his books. They're quite connected with category theory, and the exercises are particularly nice and in line of the theory. So I would definitely recommend this book to anybody who is into algebraic topology. It's same as it's also algebraic topology like Fulton, but it takes a completely different point of view. This is the point of view of homotopy, as opposed to homology, which is a bit harder, though it does have some homology in it. A very good book. Highly recommend this one. Next we have here topological Galois theory by Khovansky, solvability and unsolvability of equations in finite terms. This is all about the links between tomology and the Galois theory. So we see here in the first construction of Liouvillean classes of function Liouville's theory. Then we have solvability in algebraic equations by radicals in Galois theory, done topologically. Solvability and Picard-Vizio theory, coverings and Galois theory, one-dimensional topological Galois theory, solvability on Fuchsian equations, multidimensional topological Galois theory, then some appendices on straight-edge and compass constructions, Chebyshev polynomials and their inverses, signatures of branched coverings and solvability in quadratures, and then another appendix on algebraic version of Hilbert's 13th problem. Very advanced book, but yeah, if you're into this stuff, this is basically the only book out there which really does this kind of stuff. There's not many books doing this kind of stuff, the topological Galois theory anymore. Well, there's Arnold's book where he does it in problems, but that's not too rigorous. So yeah, if you're into this kind of stuff, I do recommend this book, because it's basically the only book you're going to find on this topic.